Hello everyone, today we will learn the fillet welding on the T-joint in a vertical welding position. In this lesson, you will learn the operational requirements for fillet welding on a T-joint in the vertical position, how to develop a welding plan, how to select welding parameters, how to weld qualified component meeting requirements of the welding safety, cleanliness, environment, and welding process. How to conduct a visual inspection of components according to standards. This is the construction drawing of vertical position welding on a T-joint. We can see from the drawing that the material of specimen is Q235. It consists of two steel plates, each 300 mm long, 105 mm wide, and 12 mm thick. The assembly angle is 90 degrees. When welding on a T-joint in the vertical position, with the weld on the vertical uphill, the molten metal tends to drip down under the action of arc blow and gravity, which causes overlap. It makes the weld hard to form, so the welding operation is relatively difficult. We determined the weld leg size to be 10 mm according to the thickness of the specimen. We need to weld 3 layers: the bottom layer, the filler layer, and the cover layer. In the following, we will learn the welding method and the process of this project according to the steps of preparation, assembly, welding of the bottom, filler, and cover layers, as well as inspection. Before welding, we must prepare as follows. Safety check. Ensure protective equipment is worn properly and in good condition. Clean up the worksite. There must be no flammable and explosive articles. Welding machine preparation. Check whether the work cable, electro cable, and electrode holder are properly installed and debug. Auxiliary tools preparation. Prepare tools such as grinder, welding hammers, chisels, files, steel brushes, steel rulers, and weld inspection rulers. Specimen preparation. Check the size of the specimens according to the drawing. Remove oil, grease, rust, and oxidize from within 20 mm on both sides of the parts to be welded until the metallic luster appears. This is the specimen after grinding. Welding materials preparation. According to the specimen material, we choose E5015 electrodes, diameter 3.2 mm, as they have better processing properties. The rods should be dried at 350 to 400 degrees before welding and keep warm for 1 to 2 hours. Use as needed. The next step is specimen assembly. First, pairing. Put the prepared plates on the assembling platform and draw assembling positioning lines according to the construction drawing. Then, follow the lines and assemble to plate into a T shape without any gap between. Tack welds are on the back ends of the fillet welds and are 10 to 15 mm long. Ensure the standing plate and the base plate intersect at 90-degree angle. After tack welding, check assembly position. tack weld and vertically of plates. This is the assembled specimen. Now, let's learn how to weld the bottom layer. Fix the assembled specimen vertically on the platform. Set the welding current at 100 to 102 ampere and start welding from bottom to top. During welding, hold the electrode at 45-degree angle to both plates of the joint and slightly incline downwards. Hold the rod at a 60 to 70 angle against the welding direction. This is the schematic diagram of electrode angle when welding the bottom layer. To weld the bottom layer, we strike an arc and weave it in a triangle motion. When you move the electrode to the top corner of the triangle and both sides of the specimen, remember to pause momentarily. It helps the fusion at the top corner and prevents undercut on both sides of the specimen. The crater at the end of weld can be filled with arc extinguish method. This is a schematic diagram of triangle motion. After the bottom layer is completed, clean the weld bead with steel brush and welding hammer. This is the specimen with the bottom layer completed. Now, let's learn how to weld the filler layer. Set the welding current at 100 to 120 ampere. Strike an arc at the bottom end of the specimen and weave the arc either in zigzag or crescent motion. The electrode angle is the same as that for welding the bottom layer. When the arc moves to the side of plates, pause momentarily to prevent undercuts. The filler layer should have flat surface and equal leg, which is prepared for the welding of the cover layer. After the filler layer is completed, clean the weld bead with steel brush and welding hammer. This is the specimen with the filler layer completed. The last step is weld the cover layer. Set the welding current at 100 to 110 ampere. Strike an arc and weave the electrode in a small zigzag motion. The electrode angle, electrode movement, the ending technique are the same as those for welding the filler layer. During welding, the arc shall be held as low as possible so as to effectively avoid defects such as undercut, slack inclusion, etc. The amplitude and the spacing of welding rod during lateral swing shall be uniform. Pay special attention to the fusion of the melting pool and the specimen plates to ensure good weld appearance. This is the specimen with the covering layer completed. The key techniques of vertical position welding on a T-joint are as follows. First, when welding the bottom layer with arc extension method, move your wrist slightly up and down. Pull the arc up to extinguish it. Welder's action should be neat and clean. When striking a neck, the touching point should be located at the melting pool accurately. Second, when welding the filler and cover layer, move the electrode in a consistent rhythm and change the angle of electrode and constantly during lateral swing. The joint adopts hot connection and the electrode should be changed quickly. Strike the arc when the molten pool is still at high temperature. The arc shall be started at 10 to 15 millimeters in front of the crater and pulled to the front edge of it. Continue the welding after the molten pool has reformed. After practice, we should organize tools and equipment, turn off the power, clean up the worksite, and write welding records. The surface of specimen must be cleaned up without traces of processing, grinder, or repair. Then, inspection of improper fusion of weld, slag, surface porosity, crack, and width of weld, equal lengths, undercut, verticality, mechanical damage or arc, abrasion, weld surface formation, etc., should be conducted by welder themselves, fellow welder, and the professionals according to the rating standards. Now we have finished the lesson, and I'm sure that you have already got a basic understanding of this welding operation. If you want to weld high-quality welds, you should be diligent in practice and keep exploring, reflecting, and summarize during practice. That's all for today. Thank you.